All right, AP Physics 1. This is Horner, and this is 2005 number 1 of the AP style questions. So they want us to look at the vertical position of an elevator as a function of time. So you notice that this elevator goes up in the air, and then it stops at a floor and is there for a while to let people on and off, and then it descends back down to the ground floor. They want us to write or to graph the velocity of the elevator as a function of time. And we have to be careful here because we actually want to calculate what the values are as we go through. So let's start by calculating the value for the straight part of the line here, which would be 0 all the way up to 8. So we want to go all the way up to here. So the slope here is really going to be our velocity, and the slope will be the change in position over the change in time. And for this first one, we're going to do 12 minus 0, so that would be 12, divided by the change in time, which is over 8. And so we get somewhere around 1.5. So notice that we need to graph 1.5 meters per second, which would be right here. And we need to do that for 8 total seconds. At this point, I've got a little bitty curve here, and you'll notice that it is a frowny face. So if we put our little frowny face on there, so here's our eyeballs, there's one, there's the other one, you can tell that this guy is not very happy, and so it's a frowny face. So we know that the velocity has to be a negative slope. Notice that from 8 to 10 it's accelerating, or decelerating, I guess it's slowing down here. And what we need to do is figure out from 10 over to 18, let's find the slope of this line. Well, obviously it's 0. So from 10 all the way over to 18, our slope is 0, so we don't have any velocity. Let's go ahead and fill that one in from 10 to 18. We also probably can go back and from 0 to 8, we can fill in the 1.5 for our velocity. And now we need to do a straight line going from 8 to 10, because that's what happened is it's decelerating there. How about from 18 to 20? Looks like it's doing the same thing. We've got another frowny face here. So it's got to be decelerating. We've got a curve that slopes facing down. So let's go ahead and skip the 18 to 20 for right now. Go ahead and go from 20 to 25. And from 20 to 25, we need to find the slope from 20 to 25 seconds. So slope, remember we said v is equal to the change in position over the change in time. Our change in position will be 0 minus, and here we've got 12, and that is all divided by 25 minus 20, which is 5. And so we end up with a value somewhere close to, let's get out the calculator and actually see. We know it's going to be 2 point something, so we're going to take 12 divided by 5, and we get about 2.4. So it's not quite 2.5, but 2.4 meters per second. This one's also meters per second. So we're going to go to 2.5, and just above 2.5 is 2.4. And we need to do that until 25 seconds. So we're going to go straight across, but we're going to stop right here. We don't go any further because the graph doesn't show us anymore. Now we can do our straight line from 18 down to 20. And we now have the correct solution for this graph. This graph, if I was grading it, would be worth 1, 2, 3, 4, 5 points. The College Board, when they grade it, they only give you 2 points. So you get 1 point for having these 3 flat lines, and then the College Board will give you 1 point for having these lines. Probably give you 2 points, they'll probably give you 1 for each one, and they have to have the right slope. And that is the end of this problem.